In this video, we're going to talk about how to simplify square roots, simplify radicals, and even ones that include variables. So, just to start off real quick, a square root. To find a square root, we need two things that are the same that multiply to get to that thing. Okay, what does that mean? Well, if I have the square root of 36, I need two numbers that are the same that are multiplied together that get me to 36. So, 6 times 6 is 36. So the square root of 36 is 6. Same thing for 100. Two numbers that are the same that multiply to get to 100. 10 times 10. So the square root of 100 is 10. For 49, 7 times 7 is 49. So the square root of 49 is 7. This can work with variables too. And any variable that has an exponent that is even is a square root. Is a perfect square. So when we take the square root of x squared, two things that multiply that are the same to get to x squared, x times x is x squared. So the square root of x squared is x. With x times 8, x to the fourth times x to the fourth equals x to the eighth, because remember, when you multiply things with the same base, we add the exponents. So x to the fourth plus 4 equals x to the eighth. So the square root of x to the eighth is x to the fourth. We can even have a situation where we have numbers and variables together, whereas 100 is the coefficient of x to the 10th. So when that's the case, we have to take the square root of 100, and we also have to take the square root of x to the 10th. Well, the square root of 100, like we did before, is just 10, because 10 times 10 is 100. And the square root of x to the 10th, because 10 is an even number, 10 divided by 2 is 5. So the square root of x to the 10th is x to the 5th. The reason why I divided 10 by 2 is because x to the 5th times x to the 5th equals x to the 10th. All right. Before we move on, it's very important to memorize all of these perfect squares. So, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49, 8 squared equals 64, 9 squared equals 81, and 10 squared equals 100. This will be very, very important as we go forward to the next part of this video. So please remember all of these. All right. So, unfortunately, life is not always great, and the number inside the radical is not always a perfect square, such as 12. There are no two numbers that are the same that will multiply to 12. But there's still something that we can do to make this radical look a little bit nicer. What we can do is we make what are called branches, or what I like to do is I like to think, okay, what perfect square that I can multiply by something else can get me to 12? Well, I can go back to my perfect square page. What is the greatest number here that goes into 12? Well, it's 4. So, I write 4 in here. Now, 4 times what gives me 12? 4 times 3. So now we're in a decent situation here because one of these numbers is a perfect square, the one that we just chose, 4. So the way we simplify a radical is by taking the thing that we just put in here that is a perfect square and taking the square root of it. So what is the square root of 4? 2. We can't do anything with 3 because it's not a perfect square, so we leave it inside. So our simplified radical is 2 radical 3. We look at the next one, 200. What is a perfect square? What is the biggest perfect square that goes into 200? Back to this page. We look, and look at that. 100 is the biggest one that goes into 200. So we can rewrite the square root of 200 as 100 times 2. And the reason why we're going to do this is because we can actually take the square root of 100, which is 10, and then we can't do anything else, so we have to leave the 2 alone. So we have 10 radical 2. All right. The next one, 18. What is the biggest square root that goes in? What is the biggest perfect square that goes into 18? We look on our perfect square list, 9. So we can split up 18 into 9 times 2. Now we can take the square root of 9. So when I do that, it will come out as a 3. I can't do anything with 2, so I keep it as 3 radical 2. The next one, 72. What is the biggest perfect square that goes into 72? I look, and I see 36 goes into 72. All right. So I'm going to split up 72 into 36 times 2. And I can take the square root of 36, which is 6. So I'm left with 6 radical 2. But here's the thing. People tell me all the time, Mr. Brown, I don't know what the biggest perfect square that goes into 72 is. Well, there's still a way that you can get the right answer. So, if you say, okay, well, I don't know the biggest one, but I know that 4 goes into 72. All right? So, 72 divided by 4. Sorry about that. 72 divided by 4 is 18. So we can split this into 18. I'm sorry. Put the perfect square first. 4 times 18. Well, the 4 can come out of the radical as a 2. So I get 2 radical 18. Well, is 6 radical 2 the same thing as 2 radical 18? Well, let's wait a second, because look, 18, there's actually a perfect square that goes into 18, and that is 9. So we can split up 18 into 9 times 2. We keep our 2 outside the radical. So now the 9 will come out as a 3, and the rule is when you do this, we have to multiply the 2 times the 3 that we're getting. So we have 2 times 3 radical 2, which will wind up being 6 radical 2. So it actually is the same thing. So if you don't know the biggest perfect square, as long as you know a perfect square, you can chip away at it, and you can keep making it smaller and smaller until the number that is in the radical does not have any perfect squares that multiply to it. Okay. So for the lack of time, and I don't want to bore you, I will move on to the ones that have variables in them. So for the first one, 4x to the third, we have to consider this as 2 different things. We have 4x, and then we have x to the third. So the 4 can actually come out as a 2. That can come out as a 2. So I'm left with 2 radical x to the third. So the thing is, x to the third is not even. The 3 is not even. So it is not a perfect square. But we can change this the same way we changed the numbers to make this as x squared times x. Well, why would I do that? Well, the reason I would do that is because x squared is a perfect square. This is now a perfect square. So I can do the same thing I just did with numbers, but now with the variable. So when I take the square root of x squared, I get x. So that will come outside as an x. So now, just like I did for the last example, when we take something out of the radical, we have to multiply it by whatever is outside of the radical already. So 2 times x is 2x. And what's left is just x inside. So this is our simplified radical. For 3x to the 8th, 3 is not a perfect square, and there is no perfect square that is a factor of 3. So because of that, we can't do anything with the 3. But x to the 8 is even, so it is a perfect square. The square root of x to the 8th is x to the 4th. Because x to the 4th times x to the 4th is x to the 8th. We have to leave the 3 because we can't do anything with it. So that is our final answer for the next one. 4x squared times y. 4 is a perfect square. X squared is a perfect square. Y is not. So we can't do anything with y. But with 4x squared, we can take out 4 as a 2, because the square root of 4 is 2. And the square root of x squared is x. And then we can't do anything with the y, so we leave it inside. So that's simplified. For the next one, we have 13x squared y to the 4th. Same thing as before. 13 is not a perfect square, so we can't do anything with it. X squared is, the square root of x squared is x. The square root of y to the 4th is y squared. So I have x, y squared. That is my square root. And when I leave, I have to leave inside my radical what is not a factor of a perfect square. So I have to leave the 13 inside. All right. Now this one. So 50 is not a perfect square, but I can multiply 25 times 2 to get to 50. Why would I do that? Because 25 is a perfect square. So I can take out the 25 as a 5. I can take out the x squared as an x, because the square root of x squared is x. And now the problem is, so let's just, at this point, let's just rewrite what we have left in here so we don't get confused. Because we can do this in steps if we want to. So now I have this. I'm not done yet, because even though y to the 7th isn't a perfect square, I can multiply, and I can bring this down as 5x. And then I can have y to the 6th times y. The reasoning for that is because y to the 6th is a perfect square, because 6 is even. So I can bring this outside, take the square root of it. So I get 5x, y to the 3rd, and then what's left inside? 2y. All right, last one. So 9 is a perfect square. So I can bring that out as a 3. So I have 3, and what's left? X to the 3rd, y to the 5th. I can change x to the 3rd to x squared times x. I could change y to the 5th to y to the 4th times y. And I'm doing that because now I have that is a perfect square, and that is a perfect square. So I can take the square root of x squared, I get x. And I can take the square root of y to the 4th, and I get y squared. And then what's left inside my radical is my x and my y, right here. So that is my answer.